Okay, when I left you in the last video, I had set you down to this challenge to create the toDim user input class, where you were to define a two-dimensional array of doubles with 2 rows by 3 columns, to ask the user for values and store them in the array in row major order. Then you print the array the 3 different ways that we did previously. And if you've done this correctly, your output should look like this, roughly. So let's take a look at the code to do this. This is at least my version of the code. You can see, of course, I need to import scanner up at the top in order to use the scanner object. Then, in my main method below, I first create my 2 by 3 array of doubles. So double brackets, brackets, numbers equals new double. And then in these brackets, I have a 2 and a 3. Then, my job is to fill the array with user input. So I have to first create a scanner object, and then I just printed one command to enter 6 numbers. Then I said I wanted to input those values in row major order, which means I'm going to enter my row major loop. My row major loop is the loop where my outer loop controls the rows and my inner loop controls the columns. And all I'm doing inside that loop is, instead of printing each element, I am valuing each element with in.nextDouble. So numbers of row col equals in.nextDouble. So basically, when row is 0, col starts at 0, and numbers of 0, 0 gets the next double. And then this inner loop loops, and now it's numbers of 0, 1 that gets the next double. And then the inner row loops, and it's numbers of 0, 2 that gets the next double. Then the inner loop loops again, but we're out of columns. So the outer loop loops. And now it's row 1, column 0, and row 1, column 1, and so on and so forth. Then it was a simple matter of printing them in table form, in row major order, and in column major order. You can pause the video if you want to see this code in more specifics. You can see here is my loop for printing in table form. Here's my loop for printing in row major order. And here's my loop for printing in column major order. I'm moving through this quickly because this is stuff we did a few minutes ago. But you'll see that if you've done this correctly, your output does go like this. So for instance, when I run this, it's going to ask me to enter 6 numbers. If I just enter any 6 numbers, like 1, 4, 8, -5, -9, 7, it will print them in table form in row major order, and then traversing on each line in row major order, and then on separate lines in column major order. Now, at this point, I'd like to point out to you one of the reasons we do this row thing in here instead of, say, 0. Because, I mean, in this particular case, for instance, we have what we call a rectangular array, which is an array that has the same number of columns in every row. And so this row is not really necessary. I could just put a 0 there because every row, including row 0, has the same number of columns in it. Well, I just want to point out that the reason we do that we put row in there whenever we can, is just because of the concept of ragged arrays, also known as jagged arrays. So for instance, let's say I were to create a two-dimensional array like this. Int brackets brackets matrix equals, and in the first row, I'm putting an array of 5 numbers. In the second row, an array of 4 numbers, and then 3, and then 2, and then 1. We have what's called a ragged array. In this particular case, it happens to be what we call a triangular array, where the number of values either decreases or increases by 1, and we get the shape of a triangle. You can see that I've shown you what all the lengths are here. Matrix.length is 5 because there are 1, 2, 3, 4, 5 rows. Matrix of 0.length, which is that first row, is 5. Matrix of 1 dot length, the next row is 4. Matrix of 2 dot length is 3. Matrix of 3 dot length is 2. And matrix of 4 dot length is 1. And here's kind of a picture of what's going on here. In each of the 5 rows of this matrix, we have different one-dimensional arrays. So what we end up having here is a ragged array. And I mentioned to you previously that if I were to say put 0 here, in this particular case, we're going to end up getting an array index out of bounds error, or an array index out of bounds exception, because matrix of 0 dot length is 5. And so when you get to row 1, you're going to try to get out to that 5th element, which does not exist. And you're going to end up with an array index out of bounds exception. At this point, I would like to talk to you about just a couple other quick algorithms. There are a number of different common processing algorithms for two-dimensional arrays. Most of these we're going to talk about next class, but I just want to briefly show you numbers 1 and 2, largely because these ones we've already done and we don't have to do again. I just want to show them to you. So for instance, I want you to pause the video right now and take a look at this code for a minute or two. Okay, so this code is code that will receive the values of a two-dimensional array from the user, and then just print that array. You've already done this. The major thing is that inside of our row major loop, we just need to receive input from the user. Here's an example of virtually the same thing, except what if I want to fill that array with random numbers instead? So you'll see I create my array the same way as usual, and I have my same row major order loop as usual. The only difference is, though, that matrix row col, or in this case matrix row column, is equal to a random number from, in this case, 0 to 99. And then I can print that array, and I would end up with something like this. So at this point, I'd like to kind of pause in the lesson. We're going to continue these other common processing algorithms, 3 through 8, in class next. But I would like to take a moment to introduce program number 4 at this time, which has been posted on Blackboard. Now, you're going to learn a little bit more that will help you with program 4, so you might not be ready to do all of program 4 yet, but I want to explain program 4 to you now. So this program, this problem asks you to write a program that prompts the user to enter a 3x3 matrix of double values and tests whether the matrix is a positive Markov matrix. An n by n matrix is a positive Markov matrix if the following is true. Each of the elements must be positive, and the sum of the elements in each column is 1. Now, you know enough to do most of this program at this point. You know enough to create a 3x3 array. You know enough to prompt the user to fill that array. You also know enough to run through each of the elements and determine if it is positive or not. That's simply just the process of running through the array in row major order and just checking if each element's positive. And if any element is not positive, you're just going to return a false. You do not yet know how to sum the elements in each column. We're going to talk about that next class. But between now and then, you can get started on this doing the stuff that you already know. Here's a sample program running. When I enter a 3x3 matrix like this, for instance, this is going to the program is going to first tell me what the sum of each column is. So the sum of the columns is 1.0, 1.0, 1.0. It is a Markov matrix because it meets the 2 criteria. Each of the rows add up to 1, and every element is positive. But if I were to do the running like this, where I enter this matrix? Well, it gives me the sum of the columns, which does happen to be 1.0, 1.0, 1.0. So it does meet the second qualification of a Markov matrix. However, you can see that one of those elements is -2, so it does not meet the first qualification, that all of the elements be positive. So it's going to tell me it is not a Markov matrix. So here's how the assignment will be graded. Just like usual, the name of the class must be your Kane email ID _ program 4. That's worth 2 points. You'll have a comment at the start of the program with your name and a description of the program. That's worth 3 points. I want a comment before each method explaining what the method will do, 5 points. And all of the methods you make will be called from the main method. That's worth 5 points. There will be 2 methods which will be called from the main method. First, you're going to have a method called createArray, which will return a 2-dimensional array of doubles. Now, returning a 2-dimensional array of doubles is really the same as returning a 1-dimensional array of doubles. We've done that before. You've written this createArray method before. So your main method will call createArray, and the createArray method will create a 3x3 2-dimensional array of doubles. It will prompt the user for values. It will store those values into the array in row major order, and then it will return the array to the main method. Then we're going to have a second method called isMarkovMatrix, which receives a 2-dimensional array and returns a Boolean, which you know is true or false. What this method is going to do, the main method once again is going to call this isMarkovMatrix method, feeding it the array that it received previously. And this method will print the sum of each column in the array as is shown here, the sum of the columns 1.0, 1.0, 1.0. Then it will return false if any value in the array is negative. So simply loop through the array in row major order, and if any number is less than 0, you're going to return a false. Then you're going to have to do another loop, because this loop will have to check all of the sums, and if any of them are not equal to 1.0, it will return a false. Note that you can't do that in step 1, because in step 1 you need to print all of them, even if one of them does not add up to 1. So you need to loop through printing all of the sums. Then you'll need to loop through again, checking those sums, and if any of them are not equal to 1, you'll return false. Finally, at the very end of this method, you will return true, because if you've hit that point, it means you've passed all of these tests, and it is a Markov matrix. The main method will receive that, and using an if statement, will print it is a Markov matrix, or it is not a Markov matrix. And so here you can see the rubric spelled out. In your createArray method, each of those 3 things gets you 5 points. In your isMarkov matrix, returning true or false gets you 5 points, printing the sums gets you 5 points, and being correct for all values gets 10 points. This assignment is worth a total of 50 points. We will talk about this assignment a little bit more in class next time I see you. You can see that it has been assigned today, and it will be due on February 20th, which is 12 days from today. You should have a little bit of time to work on this in class, next class, and you'll have plenty of time to ask me any questions. But for now, I really do suggest you get started, at the very least, writing the createArray method and beginning your isMarkov matrix. At any rate, that's it for today, and we will pick up from here in class next time I see you.